Okay, so starting off with question number 1. Given that A and B are positive constants on separate graphs, sketch the graph with equation y equal modulus 2x minus a and y equal modulus 2x minus a plus b. So I think we've kind of discussed these kinds of things before, right? So you all know how to draw the modulus 2x minus b graph and all, 2x minus a. So this is a simple theory. And for this one, I think I've told you all a strategy here, isn't it? For modulus 2x minus a plus b. So there is a certain strategy we use. We use translations here. Can you all remember? So we have kind of discussed it before. Okay, anyway. Question number 1, part A, Roman number 1, y equals modulus 2x minus a. So what do you do here? First, you ignore the modulus sign and you just draw the whole graph, right? Right? Are you guys with me?
Yes.
When you cut the x-axis, y is 0. 0 equal to 2x minus a. So a equals 2x, which means x equals a divided by 2. And then when you cut the y-axis, x is 0. So that gives you, when you cut y-axis, x is 0, y equal 2x. So 2 times 0, isn't it? 2 times 0 minus a. So y equals minus a. So now you have the x-axis cutting point and the y-axis cutting point. So just draw the graph. So when you draw the graph, you get here x and y. So x cutting point is half a, y cutting point is minus a. So minus a, half a. So this is how the original graph looks, right? Did you all get this?
Yes.
So this is the graph. Anyway, this is how the original straight line looks like, y equal to x minus a. But you're going to draw the modulus graph, which means the part of the graph that goes below the x-axis should be reflected up, right? The part of the graph that goes below. So this section should be reflected to the positive y-axis, y-axis, not y-axis, the positive y values, right? So then all you have to do is to just reflect it. And then this cutting point, so you have to name the cutting point. This cutting point becomes positive way. And then you can remove this part, right? So remove the part of the graph which is below the x-axis. That's the whole point of the modulus graph. Okay, and then make sure you also name the graph in an event you need it somewhere. The original graph we drew was y equal to x minus a. And then the reflected graph equation is, yeah, you can talk with me. The reflected graph equation is y equal
minus 2x plus a.
Plus a. Okay, minus 2x plus a. So this is the first one. If anyone has any issue, just let me know. Talk with me. Don't be silent. The chat is there. Just make sure you talk and you let me know if there are any doubts. Okay. So then the next thing that we do is, okay, so the first graph is done. Roman number 1 is done. Then Roman number 2, y equal modulus 2x minus a plus b. So how do you do this one? You can see it's the same thing as Roman number 1, but just it has a plus b. So how does it affect the graph? How does it affect the structure of your graph? Do you think you have to kind of open brackets and find x-axis, y-axis? Do you have to go to that extent?
No, simply shift the graph upwards, right?
The graph up, because you can very clearly see this b is definitely out of x. Okay, it's not with x, which means it's affecting the y coordinates. The graph translates up exactly, right? So so your graph, all the y coordinates, you simply need to add b. You add a b value to your y coordinates. So that means I think so. What you need to do is you have to look at this graph and draw the Roman number 2 graph. So all these the y-axis cutting points and the vertex, you must give the coordinates. So this is Roman number 1, Roman number 2. So the vertex coordinates and the y-axis cutting point coordinates will give you. So it will give you. This is x, this is y. And so this cutting point, when the y, now this is 0 comma a. So you know the y coordinates, you add b to all the y coordinates. So you add b, which means what happens to the y cutting point? It becomes, what happens to this cutting point? It becomes
0 a plus b.
Sorry, 0 plus B?
No,
A plus
0,
B.
A plus B.
A plus B, 0, comma,
Yeah.
A plus B, the
Yeah,
y
yeah.
coordinate. Yeah, so that means it goes a little bit up. So it goes 0, comma, A plus B. Okay, and then the vertex coordinate was A over 2, comma, 0. So you add B to the y coordinate, which means the vertex will go a little bit up, right? So it will move
Yeah.
up, and then you get A over 2, comma, B, right? So whatever that B value is, so you get your vertex over there. Same graph, just just that it moves up. Okay, so the exact same graph, but it moves B units up. So do you think you could tell me what the equation of the straight line is when it moves B units up? Is it difficult to get the equation of the straight line? So you are moving B units up, right? You are moving this straight line, B units up. You are moving this straight line, B units up. So simply y equals what now?
2x minus A plus B.
Plus B. You just have to add B to both of these graphs. That's all. Okay, so the new equation becomes.
The graph
I think it's better you write. I mean, let's say I think it might. I'm writing this in an event. You need it for part B. That's why. So anyway, having an idea about the equation of the graph is better for that. Because in an event, if you, especially for the next part, I think there's a part to solve, right? So let's see if we need it in an event. We need it's easy because we have marked, and again we don't have to waste time trying to find what the graph is. Otherwise, you have to again think the part where you drift the graph and try to find the equation again. So marking the equation as soon as you draw the graph is the best because you know exactly which graph you drift and which one you reflected. Okay, so then I took both of those graphs, added B, and I got the Roman number 2 graph. Okay, so it's not related to Roman number A actually. I mean part A. So I just marked the graphs for the, I think I in the event that I need it for part B. Then given that the equation modulus 2x minus a plus b equal 3 over 2x plus 8 has a solution at x equals 0 and a solution at x equals c, find c in terms of a. So I think you can see modulus 2x minus a plus b is the graph that we have drawn in Roman number 2, right? Modulus 2x minus a plus b is the graph that we drew in Roman number 2. So this graph, they are equating it. So it's equal to 3 over 2x plus 8 means it's another straight line. So 3 over 2x plus 8, they say it has a solution at x equals 0. So very clearly they say there is a solution at x equals 0 and at x equals c. So there is a solution at x equals 0 means, children, what do you understand? Now part B, you have, what was it? Modulus, yeah, I need to remember it. Modulus 2x minus a plus b. Modulus 2x minus a plus b equal 3 over 2x plus 8. Am I correct? Did I write the question correctly? So they want, and they say they are now you know the modulus 2x minus a plus b is the graph that we have drawn in this Roman number 2 here. Okay. Then 3 over 2x plus 8 is going to be, and completely it's another graph. So it's actually when you equate this, so you are equating two graphs in the sense it's the place where the two graphs are meeting, isn't it? So you are trying to solve the intersecting point of two graphs. So already 2x minus a plus b graph has been drawn. So now what I need to do is I have to now consider to draw y equal 3 over 2x plus 8. I have to draw this graph. And when I'm drawing this graph and when I solve it with this other, the other graph, which is y equal modulus 2x minus a plus b, they tell me that there are two solutions. One solution is at x equals 0 and the other solution is at x equals c, where, okay, so c has to be found. But there is one solution at x equals 0. Okay. So let me try to, first let's try to draw this graph. I'm going to draw the part B graph kind of like on top of the earlier graph. So when I try to draw y equal 3 over 2x plus 8. So what happens when you cut x-axis, y is 0. What do you get? When y is 0, you get 3 over 2x plus 8. You get minus 8 equal 3 over 2x. Check my simplification. I get minus 16 over 3. Is that correct? X-axis cutting
Yes,
point.
teacher.
Then the next one, you again get the place where your graph cuts the y-axis. So that is when x is 0. So when x is 0, you get y equal 3 over 2 times 0 plus 8, which gives you y equals 0 plus 8, which is y equals 8. Am I going too fast?
No, teacher.
Okay, right? If anyone needs me to explain something, just let me know. So we get the point y equal 8. So now the thing is you need to draw this. Now when you draw this, if I draw this in another diagram, okay, so I mean this is how you would get the graph. I mean you would get the graph, this is x and this is y, and the x-axis cutting point is minus 16/3, y-axis cutting point is 8, and you draw your graph like, I mean in this manner, right? So you draw your graph in this manner, right? I mean, this is what you draw. Okay. So this is the 3/2x plus 8 kind of graph. That's the graph you would get, right?
Yeah.
The 8 cutting point. But now they say when you draw this graph, I hope you guys can understand what I'm trying to do here. So when I draw this graph, on top of this graph, they say there are two cutting points, it seems. There are two cutting points, one at x equals 0. So x equals 0 means it's actually coming over here, right?
Yeah.
One at x equals 0, the other one at x equals c. Okay, so that means if there are two cutting points, means this graph kind of needs to be, that there needs to be two intersecting points, isn't it? I mean,
Yeah.
because they say there are two intersecting points, one is at x equals 0. So that immediately kind of, now I know x equals 0, if there's intersecting point. So at x equals 0, I kind of know the y value also. It's y equal 8, right?
Yeah.
Can you see? It's y equal 8 also. So actually, then I can, I mean, I hope you guys can understand. So if I draw this this particular graph on top of this, it needs to meet this graph in two places. So one is at x equals 0, that they have told. X equals 0 is a solution. They've told us in the sum. So then it has to go like this. And I know from by, I mean, when I know from by fact that the 3/2x plus 8 graph, when x is 0, y is 8, which means this 0 comma a plus b is 0 comma 8, right?
Yeah. A
Yeah.
plus B equals
Right.
8.
So that gives me the figure that a plus b equals 8.
Yeah.
So that means I can get the value of b is 8 minus a, because they want our answer only in terms of a. Okay, so now the other cutting point is over here. So this is the point that they say as x equals c, right? Because they say there are two cutting points, x equals 0 and x equals c. Your task is to find the value of c in terms of a. This cutting point, this is the point that they say x equals c.
Yeah.
Okay, so you have to find that c. So how do you find that? Obviously, what you need to do is you have to solve the pair of lines simultaneously. So this is the y equal 3/2x plus 8. And this is the y equal 2x minus a plus b. Can you see why I named the graph also? So naming the graph is important. Then, I mean, when you come over here, you immediately know what you are working with. So what I do is I take these two graphs and I solve them simultaneously. And I find this x cutting point. Okay? Are you guys with me? Is it too much?
No, teacher.
No, teacher.
So y equal 3/2x plus a and y equal 2x minus a plus b. So equate them. 3/2x plus 8 and 2x minus a plus b. And now see the advantage is, now I'm trying to make x a subject and my x should come in terms of a. But you can see there is a here and there's a b here. So
B
see,
8 minus.
yeah, for b we can replace 8 minus a, because that's why they gave you this information. That x equals 0 is a cutting point, so that you can get a substitution for your b. So b can be replaced as 8 minus a. So I think this is kind of a tough question with this one, right? So okay, 3/2x plus 8 equal 2x minus a plus b. B is 8 minus a.
Yeah.
That this guy, b is 8 minus a. So now it's a matter of making x a subject. So I think I'll bring the x terms to one side. I'll bring the 3/2x here and bring the other guys to the other side. So I end up getting 8 minus a is minus 2a. Bringing them here, I get plus 2a. Plus 8 comes here as minus a. Is that okay? Then 2x plus 3/2x goes to the other side as minus 3/2x. Is that okay? Am I too fast or?
No, that's fine, teacher.
So
Okay.
2a equals 2x minus 3/2. 2 times 2, 4. 4 minus 3 is 1. So that's half, ne?
Yeah, half x.
Half x, which means x equals to 4a. So this starting point is 4a. Makes sense? This is halfway. Obviously, you should understand if this is like a halfway value, the value you get over here should be bigger than halfway. So we get 4a.
x එක c කියලානේ දීලා තියෙන්නේ.
Yeah, x equals c, and they ask us to find the value of c in terms of a.
ඒකයි දැන් ටීචර් දැන් ඔතන x දාන්න නැතුව c කියලාම කන්ටිනියු කරලා තිබ්බොත් වැරදිද?
You should not use c. See, they are telling you here.
නෑ නෑ එතන නෙමෙයි ටීචර් මම කියන්නේ අර x කියන වැලියු එක අපි ෆයිනලි ඉක්වේට් කරනවානේ දෙකක්.
We equate these two guys, yeah.
Yeah, y equal 3/2 x plus 8 තියෙනවානේ.
Yes.
ඔතන මේ අනිත් එක 2x minus a plus b තියෙන්නේ.
Yeah.
ඔය x දෙක වෙනුවට c කියලා දැම්මොත් වැරදිද?
yeah,
3/2c plus 8 equal 2c.
Yeah, you could use c, no issue. Because they have told x equals c and you want to use
Yeah.
c here. That is okay. That is okay. So then, and then you directly get c, or you can write at the end here c equals 4a. Yeah, you could do that. But if you're going in this way, at the end, you need to mention that c is 4a because they ask you to find c in terms of a. Okay?
Yeah.
Okay, so moving on to question number 2. Given y equal 2x x square minus 1 to the power 5, show that dy by dx equals gx times x square minus 1 to the power 4, where gx is a function to be determined. Okay, so let's find that question number 2. So Roman number 1, given y equals 2x times x square minus 1 to the power 5, you have to find dy by dx. Okay, so it's a matter of what do you call differentiating, and here what's the rule that you're going to use to differentiate?
Product.
As a product here, right? So obviously we'll have to go with the
Product rule.
product rule. You'll have to go with the product rule. So product rule, one person stays while the other one differentiates. So here I'll keep 2x is waiting while x square minus 1 to the power 5 differentiates. So when you're differentiating, first priority goes to the outside power. So first you deal with the outside power, 5 times x square minus 1 to the power of 4. And then after you're done with the outside power, you go inside, isn't it? That's the rule. So you go inside and you get, what is it that you get inside? X square minus 1 differentiation is
2x.
2x. Okay. So you come there and then you write plus, and then x square minus 1 to the power 5 is now waiting. So that waits while 2x differentiates. So 2x differentiates to give you simply 2. Okay. So now it's a matter of trying to get this, show that. So you can see you have to get this particular look here. So actually the best thing to do is first simplify both the terms and then take the common thing out. So here I can simplify 2x into 5 into 2x. So this gives me 2 into 5, 10, 10 into 2, 20, 20x square, right? X into x is x square, and I get x square minus 1 to the power of 4. And here I get 2 times x square minus 1 to the power 5. So now what we do is take the common thing out. I think gx is a function to be determined. Okay, let's take the common thing out as much as possible.
x squared minus 4 එක එකට ගත්තා.
X square minus 1 to the power of 4. Eh?
Four.
Yeah, I think if you take that, we immediately get the show that you are correct. So taking x square minus 1 to the power 4 is better. I mean, keeping all the, factor 2 is also common. So we'll keep that in because we can immediately get the show that. Yeah. So then 20x square is staying in, x square minus 1 to the power 4 goes out here. Plus 2 x square minus 1 to the power 5. So you take the power 4 out, which means you have another x square minus 1 to the power 1 remaining inside, right? And okay with that. So you should be, so x square minus 1 to the power 4, inside the bracket you have now 20x square plus 2x square minus 2, right? So that gives me x square minus 1 to the power 4. 20 plus 2 is 22x square minus 2. Is this correct?
Yeah.
Are you all okay with
Yes.
that? I mean, you need to give it in the format that they have given, where gx is a function to be determined. So who is gx? Gx is the 22x square minus 2. Okay. So where gx is a function to be determined. Part B. So this is the dy by dx. Hence, find the set of values of x for which dy by dx is greater than or equals 0. Okay, dy by dx is greater than or equals 0. Let's get it done. So we have here, so this I think you will need to use a little bit of strategy here, isn't it? 22x square minus 2 greater than or equals 0. I think you may have gotten stuck here, right? Did you? Or were you able to manage to do this? Did you all manage to do it?
ඕක කරේ ටීචර් further max 2 method එකේ.
ඔව් ඒක තමයි කරන්නේ.
No, actually the thing, yeah,
You can
yeah,
no. Can we simply take one to the other side and like
no,
review it?
no, you can't take to the other side. Means how do you take it to the other side, Shana?
I mean, like 0 divided by something, and then we can cancel off that term. But then
No, you can't, because here you have an unknown. I mean,
Yeah.
x is an unknown, so you can't. Basically, it's like this. Now here, see, I mean, and in inequality, you have another problem. If you take a number to the other side of the inequality, and in an event, if it's a negative figure, the inequality mark should flip also, right?
Yeah.
Okay, so you have that issue. However, in here, there is one thing that can help you actually. So if you look at
Yeah.
x square minus 1 to the power 4, if you look at this term, x square minus 1 to the power of 4, what do you have to say about this particular person? What you said, Shana, can be done. Okay, what you said, it can be done, but you need to understand. Now, if you say you simply have like some, say you simply have some x into some 3 greater than some value like this. Now, you can't take this x to the other side just as a division, right? Because in this situation, x is unknown and we don't know whether x is positive, whether x is negative, what it is. So you can't take numbers like that. If you remember P1, right? I think we did sums like this. And remember, we did sums like this, 1 over x greater than 2. And then I used to tell you all that you can't take this x to the other side. Do you know why we can't take x to the other side? Why is it?
It's unknown. We do not know whether it's minus or plus.
So if it is negative and you take a negative number to the other side as a multiplication, then equal sign should flip. If it's positive, it should stay the same. So we really don't know whether it's positive or negative. So in this situation, we came up with the remedy. We multiply both sides by x square, right? So this is taught in P1. This is taught in P1. Okay, so you multiply both sides by x square. When you multiply both sides with x square, you are not doing any change, right? So x square is surely positive. Do you know about this? X square is definitely a positive figure. Regardless of what x is, x square. When you square the number, it's definitely positive. So therefore, you multiply like this, and you end up getting x greater than 2x square, and you take everything to one side, and you get a quadratic inequality. So in here, okay, that is that question. Coming back to our sum, what do you have to say about x square minus 1 to the power 4? Now this is actually a little bit of a
ඒ කොහොමත්
hard
1
Even addition.
not. It's always what?
Positive.
Positive,
right?
regardless of what you have. Now say for x, x square is positive, but when you subtract 1, sometimes it might become negative. Otherwise, sometimes it might become positive. Anyway, the main thing is outside power 4. The outside power 4 is what plays the main role here. Why? Power 4 is an even power. An even power will always make sure that this inside function, when you take an even power, it will always be positive, like similar to a power of 2. Do you agree with me?
Yes.
It's always going to be positive because power 4 will ensure that whatever you get inside, if it's positive or regardless if it's negative, power 4 even powers will always give out positive answers. So this is surely positive. This is surely positive. So that means so this is surely positive. So we need to find a set of possible values of x for which dy by dx is greater than or equal 0. Okay, so then this guy is always going to be positive for every x value. Do you agree with that? So this is the x square minus 1 to the power of 4 is greater than or equal 0 for all x. Surely, for every x, it will be greater than or equal 0. So if you put x equal 1 here, you get 0, right? You get x equals 0. So in here, in this function, all the x values are coming. You don't get anyone who doesn't give you an answer. Every x value in this function is an answer. Do you get me?
ටීචර්
Yeah. Yes. Yeah.
ඕක greater than or equal නැතුව greater than විතරක් තිබ්බොත්
Greater than විතරක් තිබ්බොත් then you can't take 1.
වන්නේ
Yeah, then 1 does
1 and minus 1 to 1 and
1 and
minus.
minus 1. Yes, very
Yeah.
good. 1 and minus 1 also. Yes, because 1 and minus 1 gives you 0. Yes. Okay. So then what you all need to know? I know this is a kind of a hard sum, but I think better that you all do a hard paper and get yourself adjusted, because when you do a hard paper, the other papers becomes easier. So anyway, what happens here is all the x values are solutions here, because all the x values inside this function gives you a positive x figure. All the x values, for every x value, this figure gives you positive x figure. So this is not an issue to us. This person is not an issue to us. So the only person who will give us an issue is the second function, the 22x square minus 2, which is a quadratic function. Can you see? This quadratic function, we will have some x values who gives us positive answers and some x values will give us negative answers. Do you get what I'm saying? So this guy is fine. So the next person we need to consider is 22x square minus 2. So when you consider this one, this is a quadratic, this is a quadratic minimum graph, isn't it? Are you guys with me? It's a quadratic minimum graph, right? So in this quadratic minimum graph, if you kind of quickly, you can sketch it also. So if you sketch it, you get y equal 22x square minus 2. So remember, I need the set of x values who makes this greater than or equal 0, who gives me y values which are positive or greater than or equal 0 basically. So what I do here is, we can quickly draw the graph also when x is 0, or when you cut x-axis. So when you cut x-axis, your y is 0. So when y is 0, you get 22x square minus 2. So you get 2 equal 22x square, which means x square equals 1 over 11, which means x equals square root 1 over 11 plus or minus. Do you agree with me?
Yeah.
So you get this, and it's a quadratic minimum, right? So then you get your graph like this. Do you agree with me? You get your graph in this manner.
Yeah.
So it's a quadratic minimum. What do I want? I want the regions that I get greater than or equal y values. Y values need to be positive. So where do I get positive y values? In this graph, where do I get positive y values? I get
X smaller than
this side and this and the other side, right? So for x values smaller than minus 1 over root 11, and for x values greater than plus 1 over root 11. Do you guys see that? For x values behind this, your y values are all positive. See? Do you guys see? This is P1 actually. So what I'm doing right now, this section is P1. Isn't it? So then your x values, the x values that you need to get y values greater than or equal 0, x values lesser than minus 1 over root 11, or x values greater than plus 1 over root 11. Okay, so what do you guys think about this? Ask your questions.
So that's the final answer to you.
That's the final answer here, right? Yeah, what do they want? Hence, find a set of values of x for which dy by dx is greater than or equal 0. Yes, that's all.
Yeah.
That's
So do you,
all.
since it's a 2-mark question, what are the methods we should show and like
This is it.
what can we skip?
You can write. You don't need the graph because it's a quadratic. Quadratic inequalities. You know how to solve it since P1 also. No? So you can,
Yeah.
if you can do it without the graph, do it. But make sure that you have an idea how to write this properly. Drawing the graph is in a way recommended. I think. Up to you all whether you draw it or
This
not.
number line.
Number line is also good. Number line is also fine.
So do we can simply write 22x square minus 2 is greater than or equal to 0 and then
Yeah.
solve from
Work
there.
with that because the thing is this. Now what I want here is the x values who gives me positive figures. When I put x values, what are the x values I can use here that makes this function greater than or equal 0? What are the x values I can use to make this person positive? So you can see in this, now this person is factorized. There are 2 factors here. So this first factor, when I come take it, like you can see every x value, regardless whether x is negative 100 or negative 1000 or whatever it is that I use here, this, whatever the x value we use here, this factor, because of the outside power 4, it is always positive. It's always positive. So I always get positive answers from this person. So for this one, all the x answers are correct. All the x. So I get all the x figures from this one. For this one, for this factor, the answers of x, which gives me positive answers, are x is element of all real numbers, all the real numbers. All the x values on the number line are correct for this. But for the second factor, the quadratic one, for that you can't take everyone, because in the quadratic graph, for some x values you get positive y's. For some x values you get negative y's. So I only need the x values who gives me positive y's. So I want these positive ones. The place where the graph gives where the y values are positive. So I get that in the quadratic graph, I only get it for a section of x values, not for all the x values. So I get the positive y values when x values are less than minus 1 over root 11, and when x values are greater than 1 over root 1 over 11. But for the other one, I get positive for every single x value. So then when I combine both of them together, so I mean, you have to take both of them together, and it's like and here. So when you compare both of them together, this is the final answer. So this is the final answer. So this is like you take this with this together. When you compare both, this should be the final answer. This has all the real numbers. This has part of the real numbers. So then we can, so this range works for both. In this range, both of these inequalities are satisfied.
So then if the first part was not all real numbers and it also had a range, then we have to consider it.
Yeah, that also. Yes, you have to consider that also. Then if this guy had a range, then you have to consider that guy's range. Say this is also a quadratic. Then you have to.
මෙහෙම බ්‍රැකට් දෙකක තිබ්බනම් අපි ඒක වෙන වෙනම අරන් කරන්න පුළුවන් නේ.
Yes, but at the end of the day, you have to take everyone into one number line. Like this guy, everyone into one, and then solve it also. Okay, it's a little bit tough, ne?
Okay.
Okay, then Roman number 2. X equals ln sec 2y. Find dy by dx as a function of x. So read the question. Find dy by dx as a function of x. So when you find as a function of x, let's find x equals ln sec 2y. So differentiation of ln functions, you all know the rule. Ln fx, how do you differentiate? So ln
1 over
fx,
2y
1 over fx
into fx.
into f dash x. So this is the rule of differentiating an ln function. So if you have ln with some sort of a function, x function in, you just write 1 over whatever is inside that and into differentiation of that inside function. So that's the rule. So let's differentiate. You can differentiate if you want with respect to y or with respect to x. So since x is subjected, shall I differentiate with respect to y?
That's easy, not it?
Yeah. Whatever you all want. If you all want to differentiate with respect to x, it's up to you all. Then if you differentiate with respect to x, then this becomes x differentiation becomes 1. That's the only thing. So anyway, whatever the way you do, whether you with respect to y or with respect to x, the answer at the end should be the same. Okay. So differentiating with respect
dx over
to
dy දැම්මත් ලේසි වගේ.
yeah,
කෙලින්ම උත්තරේ.
dx over dy. Yeah, at the end you just have to turn it upside down. So when you differentiate with respect to y, x becomes dx over dy. So ln differentiation is 1 over
1 over sec 2y
sec 2y into
2 sec 2y tan 2y.
Sec differentiation is sec x, sec fx differentiation is sec fx into tan fx into f dash x. So sec 2y into tan 2y into 2y differentiation is simply 2 because we are differentiating with respect to y. So 2. I mean, you don't get any dy by dx or anything there. Okay, just 2. Okay, if you all want me to explain something again, please let me know. Just talk with me. So then I end up getting dx by dy equals sec 2y. One of them will cancel off. You end up getting 2 tan 2y. Is that okay? But you can't leave it like this because they say to give you a function. Write dy by dx as a function of x, not as a function of y. So you can't keep your answer as tan 2y. So it might look like you fully simplified, but it's not a final answer. This is not an acceptable final answer. So you'll just get 2 marks. So how do we go to get our answer in terms of x? So what should I do to get my answer in terms of x? Yeah, tell me your ideas.
Try solving that the first part and get what's
Yeah, by
equal to
solving
tan
the
square?
first part in the sense you use x equals ln sec 2y. How can you use it? Yeah, how can we use it? How do we use it, children? So remove. I mean, this is in log form, turn into index form. So how do you make it?
ln එක e to the power x වෙනවනේ ටික.
Yeah, so ln means base e. So turn log to index. So e to the power x equals
sec 2y.
sec 2y.
sec 2
So you get like this. Turn log to index. And then
t2x දාලා sec square 2y එක.
so we use, I need a substitution for tan 2y. So I got a substitution for sec 2y. So if I want tan 2y, we can use maybe we can use our inequality, not inequality. We can use our identity. What is it? Sec square 1 plus tan square theta equal sec square, isn't it? 1 plus tan square, so theta. Instead of theta, I'll use 2y. 1 plus tan square 2y equals sec square 2y. Right? So 1 plus tan square 2y, sec square 2y will give you sec 2y is ex, sec square 2y is ex whole thing square. So tan square 2y will end up giving you ex to the power 2 will give you e2x, the powers multiply e2x minus 1. Is that okay? So tan 2y will be square root of that whole thing. Is that okay? Y'all can ask questions. Please ask. Dx by dy equals 2 into root e2x minus 1. These kinds of questions are really probable in your exam. So when you make it dy by dx, it becomes, turn the other side, 1 over 2 times root e2x minus 1. So these kinds of questions come for show that sounds. So it's a popular type of show that question where they give you a differentiation to do in terms of y, and they want you to write the answer back in terms of x. So definitely you need to be prepared to do sums like this, sums in this particular format. Okay. Okay, so question number 3. In this question, it is given that the exact value of tan 20 equals t, express tan 25 degrees in terms of t. Okay, so how do we do that? Express tan 25 in terms of t. So tan 25. So tan 25 can be written as what?
tan 45 minus tan 2.
Tan 45 minus 20, isn't it? So
20.
the thing
Yeah.
is this, you need to be strategic here. Because if you want to get 25, only in terms of t, you need to use an angle that you are familiar. Now, there are certain angles that we are familiar with the values, the 30 degrees, say 45 degrees, 60 degrees. So those three values are like familiar values that we are allowed to use. So if I want to get tan 25 in terms of t, and then they've given to us the value of tan 20 degrees. So we need to use the familiar angle with this guy, with this 20. So as Abhinash is saying now, 45 minus 20 is the best way to do it. 25 is 45 minus 20, exactly. And then you immediately get the answer. So these kinds of questions are really good, creative. So then what you get here, tan A minus B. So that is tan A minus tan B, tan A minus tan. So tan 45, sorry, nearest the whole thing, tan A minus tan B over 1 plus tan A tan B, isn't it? Isn't it? So tan A minus B, tan A
Yeah, tan 45 minus.
tan B, yeah, tan 20 over 1 plus. Okay, so this is the tan A plus B rule. 1 plus tan A or tan 45 into tan 20. So now it's a matter of simplifying. Replace the tan 20, all the tan 20s with t. Tan 20 is replaced by t. Tan 45, we all know the value. Tan 45 is 1. So you can type in the calendar and check. Tan 45 is 1, tan 20 is t. So input the value. Tan 45, 1 minus t over 1 plus 1 into tan 20 is t. So 1 minus t over 1 plus t. 1 minus t over 1 plus t. Is that okay? That's the answer for part A. Then third one, part B. By using the result of part A, show that tan 25, tan 65 equal 1. So again, a strategic question, right? So tan 25, I think we know the value. 1 minus t over 1 plus t. So then again, you have to do something similar like that for tan 65, right? Did you all do that? Is that the way you all did this, or you all have some other strategy? Yeah, children?
Like tan 45 plus 15.
Yeah, 45 plus 20, right?
Yeah.
Is that the way you all did it, or do you have some other ideas? Are you all okay with what I'm doing?
Yes, teacher.
So tan A plus tan B over 1 minus tan A tan B. The reason now is we need to find tan 25 into tan 65. Tan 25 is already done in part A. Tan 65 value should be found with all. And then after that, I have to multiply those two values to show that I get a 1. Okay. So tan 45 is 1 plus tan 20 is t. 1 minus tan 45 is 1 into tan 20 is t. So this is 1 plus t over 1 minus t. Can you all see? So tan 25 into tan 65, that's what they're asking you here. Tan 25 into tan 65 equals tan 25 value we found in part A, 1 minus t over 1 plus t. Multiply by tan 65. Tan 65 is 1 plus t over 1 minus t. Can you guys see? So I think you can see easily how it becomes 1. 1 minus t would cancel off, and 1 plus t also will cancel off, and you end up getting 1. Which is your show that. Is that okay?
Yes, teacher.
Yes, teacher.
Okay, then moving on to part C. Okay, do you want more time to write? Okay, so moving on to part C. Okay, part C, show further that if 2 cos theta plus 20 degrees equals 5 sine theta minus 20. So if 2 cos theta plus 20 equals 5 sine theta minus 20, then you have to show this, okay, tan theta equal 2 plus 5t over 5 plus 2t. So how do you do that? So the first thing you do is you expand the bracket, cos A plus B. So cos A plus B is cos A cos B. So you can talk with me, cos A cos B minus, right? Minus
Minus
sine B.
sin A sin.
The other side, 5 times. So here you get sine A minus B, right? Sine theta minus 20. So sine theta cos 20 minus cos theta sine 20. Is that okay? Is that okay? Are you guys okay with this?
Yes, teacher.
Yes,
So
teacher.
I get 2 cos theta cos 20 minus 2 sine theta sine 20 equals 5 sine theta cos 20 minus 5 cos theta sine 20. So were you able to get this show that? What do you do now? What would be the ideal next step? Okay, we open the brackets. We expanded by using the A plus B formula. Okay, now what? Now what is the ideal next step to get this show that?
Take it to the other side and simplify.
Take it to the other side in the sense. Take what to the
ඒ
other side?
divide කරලා දාන්නේ.
Dividing by what, Abhinash?
No.
Dividing by what?
Cos theta. Cos
Cos
theta.
theta. So actually you can see here now you have 20 alls and you need to get t. Who is t? You know t is equal to tan 20, isn't it? T equals to tan 20. So there are two strategies here, children. The best thing to do here is the easiest thing to do here is to divide. I mean, we need to create all tans here because whenever you have a tan 20, it can be replaced by t. And also I need to get tan theta. I don't need sine theta cos theta. I don't need sine 20 cos theta. I need tan 20. I need tan theta. So what I'll do here is, I mean, you know, it's an equation. So we can do the same thing to both the sides. As long as you're doing it to both the sides, it's fine. So I will divide both the sides, all the terms. The first choice is you can divide everyone. I mean, you could do the division all together at once. Like, you know, you could divide all the terms, both the sides by cos theta and cos 20. Because cos is the base to provide for tan. Tan is sine over cos.
Yeah.
So you divide all the terms in both the sides by cos theta cos 20 because that is the base you need for tan. So when you do that, you will see certain people cancel out, certain people make the tan, and it becomes really easy. So it would save you a lot of time if you go in that path. So remember, these sorts of things can only be done for equations, and if you're doing it, you have to do it to both the sides and all the terms. Okay, so cos theta cancels, cos 20 cancels. You remain simply with the 2. Minus in here you have sine theta over cos theta. Sine theta over cos theta gives you tan theta. And here again sine theta over cos 20 gives you tan 20. Can you see? I hope you guys are following me. And on the other side we have 5. Sine theta over cos theta gives me tan theta. Cos 20 will cancel out. And here minus 5 cos theta cancels out. Cancels and you get 5 sine 20 over cos 20 is tan 20. Is that okay? Can you see how our graph, how it became so simple? Suddenly it became a lot easier for us to handle. Then you replace the next step, the tan 20 with t. Tan 20 is t, right? Can you see? So I want to make tan theta the subject. So I'll bring the tan theta to one side, this term. And I'll bring this guy to the other side. So I get 2 plus 5t equals 5 tan theta plus 2t tan theta. Do you agree with that? 2t tan theta. I just rearranged and wrote it over here. Okay. Can you all see what I'm going to do next? 2 plus 5t taking the tan theta out.
Tan theta out.
And you get 5 plus 2t. So you get tan theta equal 2 plus 5t over 5 plus 2t. 2 plus 5t over 5 plus 2t, which is exactly our show that for 5 marks. Can you all see? That is the end of question number 3. Question number 4, a scientist is investigating the population growth of farm mice. The number of farm mice, capital N T months since the start of the investigation is modeled by the equation n equals 600 over 1 minus e to the power of minus 0.25t, that is greater than or equals 0. State the number of farm mice at the start of the investigation. So these are typical questions in your P3 paper, right? So it's very commonly seen, these kinds of questions, e to the power minus 2.25t. So at the start of the investigation means what? What does it mean at the start? At the start means t is 0.
Equals 0.
So at time 0, n equals 600 over 1 plus e to the power 0, which means e to the power of 0 is 1. 600 divided by 1 plus 1, which is 600 divided by 2, which is 300. So n is 300, simply 1 mark. You can directly write 300. Okay, that's part A. So moving on to part B. Calculate the number of months that it will take the population of farm mice to reach 455. So always when you're doing these questions, take care of the units, okay? So n is the number of farm mice and t is the time measured in months. So be careful, okay? Certain questions, time might be in years, time might be in days. So in this question, time is in months. So calculate the number of months it will take the population of farm mice to reach 455. So n is 455. Sorry, n equals 455 equals 600 over 1 plus e to the power negative 0.25t. So I take it to the other side. So it's a matter of making t the subject. So 455 times 1 plus e to the power minus 0.25t equals 600. So if I take the 455 to the other side as a division, that is easier, right? Equals 600 divided by 455. So next step, the 1 plus this 1, you could bring it to the other side as a minus, right? This 1 comes as a minus. Is it okay if I did all of that at once? You can do it all at once. 455 goes as a division, plus 1 goes as a subtraction. Okay? Are you guys okay with this?
29 over 91.
29 over 91. E to the power minus 0.25 t equals 29 over 91. Okay, and then the next thing we do is we
E to the power 0.25
Yeah.
t equals 91 over.
no, I mean you turn log. This is in index form. You turn it to log form, right?
Ah,
Yeah. So you turn to log form. Either you have two ways. You could put ln to both the sides, or you could directly turn this to index form. A log to index a to the power b equals c. Log base a c equal b. Do you know what I'm talking about? This rule log base a c equals to this b. P2 logarithm.
ln less in it.
Yeah, ln, if you find ln easier, then all you got to do is put ln to both the sides. Anyway, both will give you the same answer. Then the minus 0.25 t comes to the front, ln e stays here, ln 29 over 91. So ln e becomes 1, ln e becomes 1, and then time equals, the minus 0.25 is a multiplication, so the minus 0.25 goes as a division. Minus 0.25 goes as a division, ln 29 over 91. Type the whole thing in the calc and you can get the number of months. So can I have the number of months? Calculate the number of months it will take the population to reach 455. How many months? Type in the calc. How many months are we talking about? Before I get
4.57.
2.457.
4.57.
91. Yeah, 4.574. 4.574.
මේක නිකන් months වලින් එළිය යහකි.
Yeah, 4.574 months. Have they told us to round it off or anything? Calculate the number of months. So number of months that it will take to reach 455. So to reach 455, to exceed, they have not told to exceed, right? So to reach 455, you will take 4.574 months. So yeah, you can keep 4.57 months. Or you could say 5 months, because at 4.57 4 months totally and another part of the fifth month. So then you at the end of the fifth month, after 5 months, your population has exceeded 455, right? So when does it take to reach 455? Right? Yeah. So the time it will take the population to reach 455. Yeah. So it should be 4.57 months. It should be 4.57. Because they want the time when it reaches 455, not when it exceeds to the nearest month. So just keep it like that. Okay, then part C. So moving on to part C, I hope you guys are done writing. Show clearly. Part C is the differentiation, right? So show clearly that dn by dt equal 1 over 4n minus 1 over 2400 n square. So how do we get that? Obviously, we know our n equation. First, let's write down the n equation. What is n? N equals 600 over 1 plus e to the power negative 0.25 t. Is this okay? N equals 600 times 1 over 1 plus e to the power minus 0.25 t. So what do we do here? We need to get dn by dt. So let's get dn by dt in the way we know. So I will obviously use what rule? What rule were you thinking of using? Here.
Quotient or product native.
Yeah. So quotient rule or product rule. So this guy is down. I'll use quotient rule. If you bring this guy up, it's product rule. Product in a sense it's just 600, right? So maybe even using this thing is easier. I'll use quotient rule. So 1 plus e to the power negative 0.25 t. Whole thing square, denominator gets squared, denominator square into denominator times differentiation of the numerator. So numerator is simply a 600. So differentiation of 600 gives you
0.
0. That gives you 0. Then minus, it's a compulsory minus in the middle, numerator times. So 600 times differentiation of the denominator. So 1 plus e to the power minus 0.25d. What do you get when you differentiate this? Differentiation of 1 is 0, e to the power minus 0.25d. E to the power minus 0.25d. When you differentiate e to the power minus 0.25d into
minus 2.5.
minus
0.2.
0.25. So then you get here dn by dt equals, this whole part is 0. And then can you all tell me what I get when I multiply 600 with 0.25? How much is it?
150.
150. So plus.
Yeah.
Minus plus e to the power minus 0.25t over 1 plus e to the power minus 0.25t whole thing square. Okay. So we get like this. So I get an equation like this. But now the thing here is I need to get the show that. So I think you might see your show that and the dn by dt that we got are like we are looking at something totally different here, right? The show that shows something you get values with n, while my the value that we obtain dn by dt is it has e to the power minus 0.25. So how do we work with this? So what is the next step? Can you all suggest me how I can, what steps should I use? What method should I use to make my answer go towards this? And you can see it's 6 marks. So it's a pretty big show that. How do I go there? What's the, what is the thing I should do here? Give me ideas.
අපේ n value එක 600 of 1 plus e to the power minus 0.25t නේ.
So actually what you're saying here is to use this equation. And now
Yeah.
you can see your show that doesn't have e to the power minus 0.25t. So what you do is you
Yeah.
make e to the power minus 0.25t subject from the main equation. So you get your
Oh.
answer in terms of it. That end you can substitute it over here and you can then use it to get your show that. Okay, yes. So then what you do here is make n the subject here. So make n the, not n the subject, make e to the power minus 0.25 to the subject. So let's do that. So here, when I take this guy to the other side, let's take it to the other side as a multiplication. You get here n times 1 plus e to the power minus 0.25t equals 600. Are you guys okay with that? And then I get the next step. Okay, so I'll write it over here. We should write this neatly. Everything should be written really neatly, children. So n times 1 plus e to the power minus 0.25t equals 600. So 1 plus e to the power minus 0.25t equals 600 over n. Is that okay? And I'm making e to the power minus 0.25t the subject. I get 600 over n minus 1. Is that okay? Children, are you okay with this? Can you
Yes,
understand
teacher.
what I'm talking? So I
Yeah.
think better to make n this common denominator. So 600 minus n over n. 600 minus n over n. So it's now just a matter of putting all those values into this e here. So replace your e to the power minus 0.25t with this answer. With this answer and simplify, and you should be able to get your show that. Sure, so it should come easily. Let's see. Okay, so I hope you guys are with me and you guys can understand. If you have any issues, please talk. dn by dt equals 150 e to the power minus 0.25t is 600 minus n over n. You get that, divide by 1 plus 600 minus n over n, and it's like the whole thing square. Can you see? So the simplification process is not going to be easy. Can you see? We have like multiple fractions here. So you can see there's a huge denominator sign. You have the main division sign here. Don't lose, sign of your main.
ඊට 1 plus e to the power minus 0.5t කියන තව equation එකක් හොයාගත්ත place එකනේ.
Yeah. I think that is
It's
also
directly available on it is 600 over n square.
Yeah. I think that is easier. Anyway, even here, if I use n, when I make this common denominator, n to n cancels and I get 600 over n again. Yeah, you guys are saying to me 1 plus e to the power minus 0.25 is directly 600 over n.
ඒක අපි හදලානේ තියෙන්නේ උතන.
Yeah, actually, we made it over here. Yes. So we could use, you all are suggesting me to use that directly over here, right? For the denominator. And then you're asking me to use this, right? You're asking me to use this here, isn't it?
Yeah.
1
Yes,
plus e to
teacher.
the power minus 0.25 is 600 over n. I hope the others can see. So what they're saying here is to use, instead of 1 plus e to the power, the whole thing, to put the whole thing at once because it saves time. Yeah, so at the end of the day, time is the most valuable asset in the exam. So anything to save our time. Yeah, so that we can directly replace as 600 over n. But remember that only substitutes the inside part. The outside square is still there, right? The outside square is it's still there. Okay. Okay, so now let's work on this dn by dt. So I think I'll work with this from 150 into 600 minus n over n divided by 600 over n. So I'm going to use the main division as a division sign. Main division can be used as a division sign. Let's work on this. So dn by dt, can you multiply 150? So I get here 150 times 600 minus 150 times n over n. Division turns to multiplication, you get n square on top over 600 square. So it's now a matter of simplifying and I think we should get our answer. Okay, are you guys following me? So 1n will cancel off here. 1n will cancel off here. Okay. So I get dn by dt equals, so what do we get here? 150 into 600
90,000.
into n. Yeah, or 150. I didn't multiply because what I did was I multiplied the n with both these figures, 150 into 600 into n, and 150 n into n is 150 n square. Denominator has 600 square. So now I think to get the show that you can see that they have separated it out. Separate the numerator, the denominator to both of these parts. 150 into 600 n over 600 square. So it's now a matter of giving the whole thing in the calc. Over 600 square. So tell me what's the answer? 150 into 600 over 600 square. So what do you get? 600 will cancel off. 150 over 600 is? Yeah, how much is it?
104.
1 over 4. So 1 over 4n minus 150 over 600 square.
1 over 2400.
1 over 2400 n square equals dn by dt, which is our show that, right?
Show that.
Which is our show that. Yeah. See, it's 6 marks. So this is the show that we got it. Okay. So I'll move on. We need some more time to write. I think we'll need some time, right? Okay, so part D, find the value of t when the rate of growth of the population of this farm mice is the largest. So be very careful here. Be really careful here. They use the word the rate of growth. So rate of growth of the population of these farm mice is the largest. So normally when we say rate of growth, so that doesn't refer to n is just the number of mice. So rate of growth of the number of mice is denoted by what? The rate of growth of the number of mice is denoted by, are you guys with me? It's
dn over dt.
dn over dt. So this is the rate of growth. So what do we need? We need, the question wants you to find the place where this rate is at its highest, where the highest possible value you could get for your rate. Do you get me? They want you to find the highest possible value you could get for your rate. Now look at this rate. The equation you have here, 1 over 4n minus 1 over 2400 n square. What does it look to you like? 1 over 4n minus 1 over 2400 n square. So thinking of your P1,
Looks
P2
like a
knowledge.
quadratic.
This is a quadratic. And also, what type of quadratic?
Negative gradient.
Maximum.
Quadratic maximum. So your DN, your rate follows a quadratic maximum graph. The rate of growth of mice follows a quadratic maximum graph, which means it looks a graph like this. Your dn by dt graph looks like this. So they want the highest dn by dt value, which means this highest value, the maximum.
Then gradient is 0, ne, teacher?
So that means you have to make the gradient of your dn by dt graph become 0. The dn by dt graph, now dn by dt has this maximum graph. So you need to get the gradient of your dn by dt graph. Do you see? That means you need to, what should you do?
We need to solve it.
Solve
Take
it?
dn over dt equal 0 නෙමෙයිද?
No. See, if you make dn over dt 0, you just get the place where your quadratic graph cuts the x-axis. Now your dn by dt graph is a quadratic. It's a quadratic graph. Think of this as a quadratic graph.
Gradient of the
Gradient of the dn by dt. Now you want the place where your, now this is your dn by dt graph. Can you see? dn by dt graph against the time. Your dn by dt graph is a quadratic maximum graph. Can you see? 1 over 4n minus 1 over 2400 n square. It's a quadratic maximum graph. You want the highest value of dn by dt. This highest value.
We have to differentiate again.
You have to differentiate again. Exactly. You have to differentiate this thing again. This. So then you need to think of this like your y. Think of this as your y equation. Y equal 1 over 4n minus 1 over 2400 n squared. So that y gives you the rate, where y describes the rate. And I want the place where my rate is at its highest. So this, the highest position of the rate. Are the boys getting this?
Yeah.
Yes, teacher.
Okay, so that is the hard thing there. So many people, what
So
they
if
do,
the differentiate කරලා 0 කරන්න ඕනද?
yes, you have to differentiate once more and make it 0. So many people make it 0 just over here. The thing is, when you just make 0, if you make dn by dt 0, what do you find? If you make dn by dt 0, you would get the highest or the lowest turning point of this graph for n. Do you get what I'm saying? If you make dn
Yeah.
by dt 0, you get the turning points of this n graph. But that n is the number of mice, the highest or the lowest value for the number of mice. But I want the highest value for my rate of growth, not for the number of mice. I don't want the highest number of mice. I want the highest value for the rate of the growth. That is the highest value for dn by dt. Do you get what I'm trying to say? So there is a huge difference in the sum. So don't make dn by dt 0. If you make dn by, it all depends on the question, what you need to make 0. So this is a little bit of a hard one. In this question, though, you don't make dn by dt 0 because they want the maximum value of your rate, the rate of growth. What is the maximum value for the rate of growth? The rate of growth follows the quadratic maximum. So then what is the highest value of that quadratic maximum? Okay. Am I making sense here? Okay,
Yes,
so
teacher.
then let's get it done. Okay, so moving this. So we have, this is part, what are we doing? Part D, right? So part D, further differentiate. So imagine your rate. So y is the rate if you are uncomfortable. So you can think of it as y. So what's the highest value? So you get here dy by dn. And you get here 1 over 4, n differentiation is 1, minus 1 over 2400 into 2n. Is this okay? And then you make it equal to 0 at the maximum. So you know very well, this is a maximum graph. This is a quadratic maximum. You could mention it also. You could mention this is a quadratic maximum graph. So at the maximum, because then, I mean, we are sure it's not a minimum, it is surely a maximum. Because it's a quadratic maximum graph, when you set your dy by dn to 0, you know you are finding a maximum point. It's not a minimum point. Okay, so 1 over 4 minus 1 over 1200 n. So that gives me 1 over 1200 n equal 1 over 4. N equals how much? Can I know the n value?
300.
300. So n is 300. So you get n is 300. So then the maximum dn by dt is when n is 300. So what do they want? They want us to find the time, right? Find the time when the rate of growth is the highest. So how do you find the time then? N
How
is
again
300.
substitute that 300 to the first equation?
Substitute that 300 to the first equation and make t the subject again. Make t the subject. Substitute n equal 300 to the first equation because they want you to find the time. So this is time when rate of growth is highest. Okay, not the time when the number of mice is the highest. No, not time when the rate, the population rate, when it changes, the time when the rate is the highest is when n is 300. So you know n equals, what was the formula again? Can you all tell me? So what was it? I remember. What was it? 600 over 1 plus e to the power.
So you should be substituted for the very
Yeah.
first equation.
Yeah, and get the t. Is this formula correct? First of all, check that.
I mean that dn over dt, right?
No,
Not the very first n.
no. Why would you put it to dn by dt? If you put it to dn by dt, the n value, then you would get the dn by dt value. Do they want you to find the dn by dt value, or do they want you to find the value of t? If you input the n value as
okay.
300, so that you get that rate, the highest rate. This rate, you get it, but they don't want the rate. They don't want the dn by dt, the highest. I mean, I want the time where you get the highest rate. I want the time here. Okay. So you get what I'm saying? So if you put n as 300 here, you would get your highest rate for that.
Yes, stage.
Okay, 600 over 1 plus e to the power minus 0.25 t. So let's put n is 600, n is 300. 1 plus e to the power minus 0.25 t. So this becomes 1 plus e to the power minus 0.25 t comes to the top. Right? 300 comes down as a division. 600 divided by 300. So then you get e to the power minus 0.25 t. 600 divided by 300 is 2. 2 minus 1, right? The plus 1 comes as minus 1. E to the power minus 0.25 t equal to 2 minus 1 is 1. So you can use either logarithm ln to both the sides, right? ln1 is 0. Wait, what? We get times 0. Did I do something wrong, Noni?
Not easy.
Minus 0.25.
Zero,
ln is 1 and ln1 is 0. So we actually get times 0.
That means the highest is at the
The
start of
highest
the.
is at the start. That means you have the highest change in population. Remember, dn by dt means the rate of growth, how fast the population is growing. So you have the highest increase in population at the very beginning. Then when the time goes up, the population the increase in population, that it slows down. The
Like
rate
increasing
of
at a reducing rate.
Yeah, so when you when time is increasing, the rate of increasing has slowed down. That means this dn by dt graph starts at time 0 with the maximum and comes down. The rate is highest at the beginning, and then the rate of population increase has gone down. Something like that. The rate of the increase of population is highest at the beginning, and then it's going down anyway. So we get here time 0. We did not do any calculation error, right? So check on it. Check on it again. N is 300, right? Yeah. 3 times 2 is 6. 2 minus 1 is 1.
In the first question also we found when t equals 0 as 300.
Yeah. Yeah. So we actually don't need to go that far also. Yeah, correct. So actually we found in the first question also n is 300, which means from there we should have figured out t should be 0 from that point itself. So we need not see that. Because in the first question we found at time 0 n is 300, so vice versa, if n is 300, time should be 0. So figuring all that out, thinking all that out is really, I mean, if you can think of that at that moment, that's really good. So even I did not think. So you can come from here to here directly without going through all these working, without going through all of this. So the highest rate of population increase, the highest rate is at the beginning, at time 0, okay? Okay, question number 5, express sine theta minus 2 cos theta in the form r sine theta minus alpha, where r is greater than 0 and alpha between 0 and pi over 2. So this is quite simple. So sine theta minus 2 cos theta is equivalent to r sine theta minus alpha. So r is obviously what? So this is 1 sine theta. So 1 square plus 2 square square root, r equals root 5, right? Is that okay? 1 sine theta minus 2 cos theta. If you want, you can open this root 5 sine theta cos alpha minus root 5 cos theta sine alpha. Are you with me? I expand this, and if you take the sine theta coefficient, I think you can directly take tan theta also. Ne? Sine theta is 1. Sine theta here is root 5 cos alpha. So cos alpha is 1 over root 5. Can I know the answer here? Alpha in radian mode. Cos inverse 1 over root 5. What's the answer? Can I have the answer quickly?
1.107.
1.107. The others, please check. 1.107. Okay. Cos inverse 1 over root 5, 1.107. Okay. Then part B. So this is part A, question 5, part A. Question 5, part B. M theta. M theta equals 40 plus 3 sine theta minus 6 cos theta whole thing square. Find the maximum value of m theta. So these kinds of things, we are so familiar with them, right? So you know exactly what you should do. 3 sine theta plus minus 6 cos theta, wait, this is the same thing. So actually it's not the same thing, right? We have sine theta minus 2 cos theta. Here they have 3 sine theta minus 6 cos theta, isn't it? So that means you must take the, you can take a 3 out here, isn't it? Are you guys with me?
Yes, teacher.
So from this inside the square bracket, I took a 2 out here because I mean a 3 out. 3 is common to both of them. So 3 taking it out, sine theta minus 2 cos theta, and outside the bracket, it's a whole thing square. Okay. And then sine theta minus 2 cos theta is equal to r sine theta minus alpha. So we found r is root 5. Sine theta minus alpha is 1.107. Is that okay?
Yes, teacher.
So n theta equals 40 plus the 3. Remember the square comes to the 3 as well here. So 3, or else we'll put it at the end. 3 times sine theta minus 2 cos theta is root 5 sine theta minus 1.107 whole thing square. So this is better, né? Makes sense to you all, right? Does it?
Yeah.
If you have any issues, tell me. So m theta equals 40 plus 3. So the square comes to all the figures here. 3 root 5 and the sine function. Everyone gets the square. So 3 becomes 9. Root 5 when you square it becomes 5. Sine becomes sine square. Theta minus 1.107. Is that okay? The square affects everyone inside. There are three functions inside the square here. 3 into root 5 into sine. So everyone gets the square. Okay. And then, you know, I have my habit where I don't like to work with these compound angles. So I will say let x be equal to theta. minus 1.107. So I use a letter that we have not used. So I always use it to make it easier for us to spot these patterns. So if you are good, I mean, if you don't want to use it, you don't have to use it. Okay. So 40 plus 9 into 5 is 45, right? 45 sine square x. Are you guys okay with that?
Yes, teacher.
Any doubts until here? Okay, so they want the maximum value of m theta. So what's the maximum value? So you need to think about how m theta varies with respect to x. 40 and 45 are constants. The only variable here is sine square x. So how does sine square x vary? So how does sine
It's
square
gonna
x
go to
vary?
maximum 1.
Maximum is 1. Sine function maximum is 1. Minimum is minus 1. So that's how the sine function works. Sine function maximum 1, minimum minus 1. I mean, that's how you work in the sine function, but now you are not working with the sine function. You are working with sine square. So what happens when it becomes sine square? What happens? The maximum. So the maximum value is 1. Squaring of 1, does it change?
No, still gonna
No.
be the same.
It's still going to be the same. But what about minus 1 and these negative y figures? You know, when you're squaring, you are not going to get negative figures, right? You don't get negative figures. So everything is going to be positive, which means the minus 1 peak will go to where? When you square minus 1, it becomes plus 1, which means the negative peaks are also going to be now positive peaks. Can you all understand? The negative peaks are also positive. So you don't have the graph at the down part. The entire graph is above the x-axis now. Because it's sine square, all the y values are positive. Okay, so then I want the m theta what maximum, right? Or minimum?
Maximum.
So m theta maximum. So this is in our numerator and everything is positive. So I want this to be as, if I want m theta to be large, I need this guy also to be as large as possible. So it's going to be 40 plus 45, right? 45 because sine square maximum is 1. So that gives me m theta maximum is 95.
85.
Sorry, 85. 85. Okay. Then the next part, this is Roman number 1. C, right? That's C. Then where is B? Oh, sorry, I'm doing part B. Part B, Roman number 1. Then part B, Roman number 2. The smallest value of theta in the range 0 to 2 pi at which the maximum value of m theta occurs. So what are the smallest theta values at which it occurs? So what are the place where you have the maximum? So you can see you have one at 90. Okay, the peaks are at 90, minus 90. This was at 270, right? These are the peaks, right? Are you with me? The negative peaks are also now positively. Are you with me?
Yes, teacher.
So now in Roman number 2, they wanted to find the value of theta, where you get the maximum. So they are when the maximum occurs, what's the value of theta in the range 0 to 2 pi? The smallest value. They want the smallest value in the range 0 to 2 pi. Okay, so the smallest value. So what you do is, m theta is the maximum. It happens when sine square x becomes 1, right? M theta maximum occurs when your sine square x graph becomes 1. Does that make sense to you? This is this value is a maximum when this person is 1. Right? Talk to me.
Yes, teacher. Yeah.
Yes. So then tell me, so what are the x values who makes it possible? The angles?
Pi by 2 and pi.
Pi by 2, not pi, right? At pi, it's sine pi.
3 pi by 2.
Pi by 2. So I
Yeah.
think to be safe, now they want the smallest value. And you've done some kind of subtractions here as well, because for theta. So my advice is you take the negative pi over 2 also to be safe, because I want the smallest value. So I think it might be one of these two, guys. Okay. So and even 3 pi by 2 you can try. Anyway, you need to get the smallest value, the smallest theta value. Okay. So then remember, we are not trying to find x, we are trying to find theta. Who is x? X is
Theta minus
1.107, which means to get theta, you need to add 1.107 to all these answers.
All that.
So I think I don't need to get this guy because it's anyway positive and
Yeah.
already a positive figure is there here to cover this. I want only one answer at the smallest positive one. So I'm not sure whether that will come with this or with this. Okay, because if this guy, when you take this to the other side and when you add, if it becomes positive, then that's the correct answer for theta. So you need to be careful of that. So the correct answer for theta, so try it out, minus pi over 2 plus 1.107, or it might be one of these two. Which of these two is the smallest positive?
The first one
Plus
is going to be
5 over
the
2.
The first
yeah.
one.
So yeah, no, first one is going to be minus. Therefore, it's
Minus.
going to be the second one.
Okay, but tell me the answer for the first one also.
Minus
one is
0.464.
And the other guy,
2.68.
have they told you decimals here? How many decimals? They've not told decimals. Okay, so then theta. So smallest theta in the range 0 to 2 pi. Smallest theta in the range 0 to 2 pi is 2.68 radians.
Same.
Okay, so that's 2.68 radians. I'll move to the next part. Okay, or do you want some time? We're moving to the next part. Part C. So there's a part C also. So part C, so it's a totally different function now, n theta. N theta equals 30 over 5 plus 2 times sine 2 theta minus 2 cos 2 theta whole thing square. Okay, are you guys with me? N theta equals 30 over 5 plus 2 sine 2 theta minus 2 cos 2 theta whole thing square. So it's a square here, right? Can you all please check the PDF? Is it a square here? Yeah, it's a square. 30 over 5 plus 2 sine 2 theta minus 2 cos 2 theta whole thing square. So there's a square here. Okay. So then what do they want you to do? Find the maximum value of n theta. Okay. So once again, the same story. So I think you can see we have sine theta minus 2 cos theta, but there is a slight difference here. What's the difference? What's the slight difference here? Mention the difference, children. What's the difference here? Now your angle is what?
It's 2 theta.
It's 2 theta. So that is equivalent to r sine, not theta now. R sine 2 theta minus alpha. Can you all understand?
Yeah.
Okay. So, you know, sine theta minus 2 cos theta. What was the answer? The answer was equal to root 5 sine theta minus, how much was the answer, children? Theta minus 1.107, right? This was what we got right for part A. You guys need to talk with me. Don't be silent. So you get this right. So now when it's 2 theta, the only difference is the theta here should be replaced by 2 theta. Is that okay?
Yeah.
So you get here 30 over 5 plus 2 times. So use a bracket here. You get root 5 sine theta minus 1.107. The whole thing square. Okay, whole thing square. So then we'll work on this 30 over 5 plus 2 times. So you know the square will affect everyone inside here. So what happens with the root 5? Root 5 square gives you 5, right? And then sine, when you square it, you will get here sine square theta minus 1.107. Is that okay? Children, give me your feedback. You get what's going on here, right? It's a square
Yes,
plus
teacher.
both the functions. So again, I'd like to use the same. See, you guys are not paying attention. You guys just said okay.
2
Okay.
theta.
It's 2 theta. See, I'm trying to see whether you guys are, you know, checking these things out. So when I pointed here and told you now this should be 2 theta, and I wrote here theta, no one was, you know, bothered to point it out. So this is 2 theta. Okay, right? So this is 2 theta here. Should be 2 theta here. So now let's use again another letter. So I prefer to use I don't want to work with compound angles. I like to work with simple angles. So let's say, what is it? What's the letter we use? Let's use letter A. So let A be equal to 2 theta minus 1.107. So please make sure you remember that you used it, okay? Because you need to come back again. So n theta equals 30 over 5 plus 5 times 2 is 10. 10 sine square A. Okay, 30 over 5 plus 10 sine square A. Okay, so the task here is to find the maximum value of n theta. So how do I find the maximum value of n theta? So looking at this, we have a fractional function. 30 is a constant in the numerator. 5 and 10 are constants in the denominator. Sine square A is in the denominator. So what do you think you should do here? Should I take the maximum value of sine square, or should I take the minimum value of sine square? So if I want...
0.
Yeah, so this is what we call as the inversely proportional relationship, isn't it? So when you want the highest value for your answer from the denominator should be as small as possible. So it's called inverse proportional relationship. So if I want the highest value for the answer, denominator should be as small as possible. So now when we consider the square of the sine function, what's the smallest value we get here? Do we get minus 1 as the smallest value for sine square? What is the smallest value we get here, children? Talk to me.
0.
0. Do the others see that? I think I drew the graph for sine square a moment ago. So I drew the graph for sine square a moment ago, and I was telling you all that these graphs, the parts of the graphs which are coming down when you take sine square, the negative values are all becoming positive. The negative peak at minus 1 becomes a positive peak at plus 1. So your graph basically looks something like this. So that means the smallest possible value you get for sine square function is 0. Can you see? The smallest value you get for sine square is 0. The highest value you get for sine square is 1. Okay, children? So smallest value you get for sine square is 0. 30 over 5 plus 10 into sine square A, so that's 0. Okay? So you get here 30 over 5 plus 0. So n theta maximum 30 divided by 5 is 6. Is that correct? Are you guys okay with that?
Yes, teacher.
Yes, teacher.
Then the next one, the largest value of theta in the range 0 to 2 pi. So a range is given. So make sure your answer is in the range. The largest value. So again, now here, I think the earlier question they wanted the smallest value of theta. So pay attention. So these are trick questions. Now here they want the largest value of theta in the range 0 to 2 pi. Do you see? The largest value in the range 0 to 2 pi at which the maximum value of n theta occurs. Okay. Tell me, where does the maximum occur? So n theta, this is Roman number 2, n theta maximum occurs at what time? When your sine square function was equal to what? N theta maximum occurred when sine square function
0.
equals to 0. So where do you get the sine square function becoming 0? Let's look at the graph. Where do we get 0 for sine square? So I think you can see we have a lot here. Sine 0 at sine, what is this figure? Pi.
Sine 5.
And again, this is 2 pi. So all of these you get 0, right? 0, pi, 2 pi. So remember, they are asking you the biggest value. Okay, so remember they are asking you to find the biggest answer in the range 0 to 2 pi. Can you see? The largest answer in 0 to 2 pi. So let's work on some values. So what are the values you could get for A? A can be either 0, it can be either pi, it can be either 2 pi. Okay, it might even be 3 pi, or you can even go further. This graph goes further, right? This next one should be 3 pi. So I just took it. Okay, anyway, I want to see the biggest value I can get inside the 0 to 2 pi range. Okay, I don't think I need to be bothered with 0, right? I don't think I need to be bothered with 0. Okay, so who is A? A is 2 theta minus. Are you guys with me? I think it might be larger than what we thought. 2 theta minus 1.107 is So I just took a few extra values, but I mean, I need to get the biggest possible answer I can get. Okay, children, do you hear me?
Yes, teacher.
Yes, teacher.
Yes, teacher.
I think the last answer here, 2 theta, we are even dividing by 2, right? Do you see? Do you see we are even dividing by 2 at the
Yeah.
end? So better to take another one. I think these guys won't come the beginning. We need to take the highest value. So I don't think we need to consider ourselves with pi also. Okay, because we are dividing by 2. Again, 4 pi divided by 2 is 2 pi. Okay, anyway. So I just took a few extra values. So the answer for theta is you have to add to 2 pi, you have to add 1.107 and divide by 2. Right? So tell me what's the answer that comes inside the range? The biggest value you could get inside the range?
3 pi.
What is the answer here? This guy? 2 pi plus 1.1.
3.695.
3.695. Right, now what is 0 to 2 pi? Your theta is between 0 to 2 pi, right?
Yeah.
Theta is, how much is 2 pi in decimals?
6.38.
6.38. So theta is between 0 to 6.38. Okay, how much is this guy?
5.27.
5.27. The other guy, 4 pi.
Ege exceed venadi.
That
6.8 gana.
6.8 something. So then the maximum theta or largest theta in the range equals to 5.27 radians. Can you all see? So this is something a little bit unexpected because they always ask the smallest value, but here they are asking you to find the largest value of theta in that particular range. Okay.